Now let's take a little deeper look at what is contained inside of the data array. Now, if you recall, each layer is actually a large two-dimensional grid of tile data. It's listed here in the JSON file as a single integer array. Effectively, this is what we call raster scan order, where each row is listed in the file after the previous row linearly. The value of each element in the data array actually has significance in itself. First off, if you see a 0 value, that effectively means that no tile has been placed in that XY position inside of this layer. Any non-zero value represents a tile index for a given atlas. Now, this is where things start to get a little bit tricky. Now, if you recall this little element here, first GID, that exists for each atlas that's listed in our tile sets array. Now, if a 0 value in the data array for a layer means that there's no tile there, that means that the first element to represent that a tile does exist must start with 1. Each atlas that exists inside of the tiled file will have an increasing first GID. Now, tiled has its own heuristics on what the first GID should be for each subsequent atlas that's loaded. We won't get into that, other than to say that you need to know what this number is. So what we see here is that if we have a value of 167 in this data array, and the first GID of the atlas starts with 1, this effectively means that 167 is the first atlas, tile number 166. Now, this makes a little bit more sense once you start getting 4 or 5 different atlas layers on there. Right now, it may seem a little bit gobbledygook. The larger issue that you have to run into is, what does 166 actually mean? Now, recall once again that the atlas that's being given to us is in raster scan order as well. So the value of 166 is actually the raster index into the two-dimensional array. With this setup, computing the coordinates for the atlas simply involves mapping the tile size to the right offset inside the atlas itself.